This is arborist Cassian Humphreys reporting from Nannup in Western Australia. I've got footage on 4 significant tree failures. These followed a wind event that started in Bridgetown two weeks ago or so. My understanding is it was a mini twister that went from Bridgetown along the Brockman Highway to Nannup. I met an old farmer who gave me the information on that. I tend to trust old farmers, but anyway, there was a relative amount of damage done in about a 45 kilometre distance, and the 4 tree failures I gathered footage on were probably the most significant. All up, I ascertained I saw around about 10 trees fail as a result of this wind event. But there's a key thing which unites all these failures, and that is wood embrittlement from drought stress. Although some of the failures were quite significant in size, and there was evidence of wood decay involved with some of those failures, particularly the marigums. I'll share more in the conclusion on this piece. Looking at our first tree failure, this is the drought gum tree, or Eucalyptus gomphocephala. As discussed, in the course of my career, I have predicted a number of tree failures, and in this case, I made the prediction to the tree owner, some weeks before this tree failed. My observations were made based on the tree's high forest crown, which prior to the failure was broader. As discussed in earlier podcasts of mine, forest trees are more prone to tree failure than field pasture or paddock trees. Panning in, we can see the collapsed branch. The vertical 5-metre limb landed on a lower branch. This is what's known as a branch breakout failure. The limb failed adjacent to an old snag, or a historic tension failure. The old snag contributed to the branch breakout failure by oxygenating the wood tissues adjacent to it. A branch breakout failure is a failure which leaves a hole in the trunk of the tree. Wood embrittlement as a result of drought stress is a major reason why this failure occurred. Zooming in on the base of the failed branch, you can see the dehydrated wood tissues so dry as to be combustible. Had the tree been hydrated, I doubt that this failure would have occurred. Hydrated wood tissues are visibly so. Wood embrittlement reduces wood elasticity, which has a similar impact. Brown rot wood decay is another form of wood embrittlement. The limb failed at around about the 40 centimetre diameter mark. Here we can see the full extremity of the 8-metre limb. The canopy still got a touch of green in it at the time that I got this data. Through ossification of the soil environment, a failure like this is preventable. Likewise, a tree's crown can be trained to be alpha. A tree with an alpha crown has had the elongation trained out of it. Moving on up the Brockman Highway, I came across this East Coast tree and a 5-metre limb failure. The limb was about 20 centimetres diameter. Though closer study revealed that there actually had been 2 limb failures, 2 tension failures, leaving 2 snags. Moving in closer on this limb, likewise, we can see evidence of major wood embrittlement. Timber that's just so dry, you could virtually light a match to it and it would burn. And it's dehydrated wood like this is visible, as is hydrated wood. It's obvious the difference. Likewise with these limb failures, dehydrated wood and elongations were primary causes. That triggered by the wind event. Though likewise with the first tree failure, had this tree been hydrated, I don't think these failures would have occurred. Truly, we should be respecting the tenacity and resilience of our Australian gum trees. With a major wind event and 45 kilometres of road affected, I saw no more than 10 tree failures, the 4 most major I documented in this study. And that's under extreme drought conditions when the timber is as dry as I've shown you. Moving on to our third tree failure. This is on a marri gum, Corymbia calophylla. Here we have another major branch failure. This failure was a branch breakout failure that occurred adjacent to an old tension failure. The limb likewise an approximate 8 meters in length and 40 centimeters at the point of failure. This limb failure is an interesting study, as we have within the failed wood tissues there's evidence of wood embrittlement from drought stress, as well as a brown rot wood decay and evidence of soft rot. This could be from the same fungal organism, or there could actually be 2 fungi present in this wood sample. This may be a side effect of the marri canker, which is certainly on the outside of this tree. In my experience of cankers on the east coast, namely Phalanus species, they cause a white rot type decay. Based on my study of this wood sample, I would say as little as 20% of the wood tissues were not occupied by fungi. In this sample I can see evidence of canker. The recent failure point, a branch breakout, was adjacent to an older failure point. This had been a tension failure. Tension failures leave snags, branch breakout failures leave holes. Our fourth case study is a drought gum tree. This is likewise a major limb failure, a tension failure. The limb that failed was approximately 9 meters long and was dead actually at the time of failure, although the tree was still retrenching resources from that largely dead limb. This limb failure was around about 50 centimeters in diameter. Our fourth and final case study is on another marri gum. This is an old field pasture tree. This tree is an interesting study as we have 2 trees growing side by side which formed a root graft or an inoculation between the 2 trees, sharing resources as well as strength and stability. Natural grafts between trunks and roots on gum trees are a part of their success story. This was the largest limb failure of the 4 case studies, a 15-meter limb with a diameter at the base of the failure at around about 80 centimeters, so very substantial. This tree had similar kinds of decay and signs of wood embrittlement from drought stress as the previous marri gum failure, with signs of soft rot, brown rot and wood embrittlement from drought stress. We can see evidence of the wood embrittlement from drought stress in this last clip. So in the course of my career, I've gathered a lot of data on tree failure, particularly in southeast Queensland. I've written some very substantial reports on this topic, and I've come up with my own hypotheses in relation to trees failing in Australia. There has been very little, if no, arboricultural science practiced in Australia compared to parts of Europe, and we don't really have that much record. So I've gone out of my way to create a record just as a part of my own learning curve. So attached to this podcast, I'm going to include some past articles. One was on a very major wind event that hit Greater Brisbane, a suburb called the Gap, in 2008, and there's a lot in that piece. And then this other piece is on wood embrittlement as a result of drought stress. Part of the reason why trees fail is because of a loss of elasticity in wood. And this is because of fungi which degrade the cellulose in wood and set wood up to be brittle and to fail. And I observed through my own study that there's a parallel to drought stress and tree failure, likewise with the wood becoming brittle. And to me, it's fairly obvious, but because that observation isn't in mainstream science connected to arboriculture, it's disregarded. But all science is based on natural observation until it's tested. And, I'm testing the equation because this piece on wood embrittlement as a result of drought stress is fair income. So those two past articles will be linked to this Treecast. I thank you for your attention.